Welcome to the presentation of Digital Signal Processing Term Project. This is Nandkishore, and the title of my project is to design and implement first order, second order, and central derivative filters, and to obtain the output for 5-second PPG signal, which is sampled at 100 Hz. So, in order to design these derivative filters, we can take help of difference equations of those derivative filters. So we know that the difference equation for first order derivative filter is given by y of n equals to x of n minus x of n minus 1 by t, where x of n is the input signal and t is the sampling period of that input signal. So from this equation, we can obtain the difference equation for second order derivative filter. Just take the derivative of this filter, which gives y2 of n equal to yn y of n minus y of n minus 1 by t. Put the value of phi of n from this expression into this expression, then we get this expression, and we just rearrange the terms. Here x of n minus 1 and x of n minus 1 becomes 2 times x of n minus 1, and this minus minus becomes plus. So the final difference equation for second order derivative filter is x of n minus 2 x of n minus 1 plus x of n minus 2 by t square. And to get the difference equation for central derivative filter, we have to take the average of two successive points of the first order derivative. So that is yc of n equal to y of n plus y of n minus 1 by 2. Substitute the value of y of n in this expression. So we get this expression. Here x of n minus 1 and x of n minus 1 gets cancelled, and we get the final expression as yc of n is equal to x of n minus x of n minus 2 by 2t. So we have obtained the difference equations for all the three derivative filters. We have just listed them here. And then our task is to implement these three difference equations in MATLAB. So there are two ways. One is using the inbuilt command filter, and also we can iteratively calculate the output and implement the difference equation. So in the starting, I have truncated the given PPG signal to get the perfect complete periods. So I have found the index from where to cut the PPG signal, and then got the perfect period PPG signal, and then using this PPG signal and feed forward coefficient for the first order derivative, feed forward coefficient is 1 minus 1, and feed backward coefficient is t. So using the inbuilt command filter and this feed forward coefficient and feed backward coefficient and the PPG signal, we can get the output for the first order derivative filter. Similarly we can find for output for second order derivative filter and central derivative filter. So this was from the inbuilt command filter, which will be used to cross check our output. And here I have implemented using iterative process, like y of output, finding the output iteratively. So for first order, second order, and central derivative filter, I have obtained the outputs and plotted the output for outputs obtained from inbuilt function and outputs obtained from implementing the difference equation using for loops, and cross check both are the same. So so we can conclude that finally we got this plot. And if we observe this plot, here we have the original input signal, PPG signal, and then first order derivative waveform, second order derivative, and the central derivative waveform. So if we look at the first order derivative waveform, then we can see that the peak of the PPG signal, that is this, can be obtained from the positive zero crossing of the first order derivative filter, that is this point. And maximum slope point, that is this zero crossing of PPG signal, can be obtained by looking at the maximum peaks in the first order derivative waveform, that is this. And if we look at the second order derivative waveform, then we can see that the foot of the PPG signal, that is this minimum point, can be obtained by looking at the second peak of maximum peaks in the second order derivative waveform, that is this point. So, and one more observation, if we compare first order derivative waveform and the central derivative waveform, then we can see that the in central derivative we have smoothed out the noise. And one more trend we can see here, that as the order of the filter increases, the noise also gets amplified. So these observations are listed here, and I have listed two applications of these derivative filters. One we have just looked is PPG signal, that is to get different points and different parameters of the PPG signal from derivative filters. And one more application is in signal processing, like with the help of these derivative filters, we can get the information about rate of change in the pixel brightness. And for challenge, one challenge we can see in this derivative filter is that as the order of the filter increases, the noise also gets amplified. And I have made a simple GUI interface for this simple project. I have taken different axes for all the three derivatives just to have comparison between them at a time. So I will just now show the demo of GUI. Okay, this is the GUI made. I will run it. We have to press load PPG signal to get the PPG signal, and then we can get the different order derivatives. This is first order derivative, then second order derivative, and central derivative. So that's all from my side. Thank you.